9.4, we're looking at our multiplication rule. So in this lesson, we need to know the difference between independent events and dependent events. So independent events means the outcome of one event does not affect the outcome of a following event. For example, if I roll a die and then I spin a spinner, those have no connection to one another. So they are not, the second event's not going to be affected by the first. A dependent event is the opposite. The outcome of one event changes the outcome of a following event. So if I have a deck of cards and I draw a card and keep it, and then I draw another card, well, what I drew the first time affects what I draw the second time. So one event depends on the other. So let's determine whether or not these events are independent or dependent. Robert draws a colored toothpick from a jar. Without replacing it, he draws a second toothpick. This is dependent because that first draw and not replacing it affects the second draw. Paula rolls a 6 on a number cube, then flips a coin that comes up heads. This is independent because the dice roll does not affect the coin flip. Allie draws a card from a deck of cards and replaces it. She then draws a second card. So this is actually independent. And the key with that is she replaces it. If I have 52 cards, I take one out, but then I put it back, I still have 52 cards. So my first draw is not affecting my second draw. You draw a red marble from a bag and then draw a second red marble without replacing the first. This is dependent, and the key there is the without replacing. Because I've taken that first red marble, that affects me grabbing out another red marble. So when we have independent events, we are finding P of A and B. So when we see and, we want to think multiplication. We are going to multiply the probability of A and the probability of B. So I have a box contains 3 red marbles, 6 blue, and 1 white. The marbles are selected at random, one at a time, and are replaced after selection. So that's why these are independent, because we are replacing the marble. So first, I'm taking a red marble. The probability of that is 3 out of 10. Times, next I'm taking a blue marble. The probability of that is 6 out of 10. That is going to equal 3 times 6, 18 out of 100, which reduces to 9 out of 50. B. I draw a blue marble, 6 out of 10. I replace it and draw another blue marble, so 6 out of 10 still, which gives us 36 out of 100, which can reduce to 9 out of 25. All right, try the next ones yourself. I draw a white marble, which is 1 out of 10, times a blue marble, which is 6 out of 10. This is 6 out of 100, which equals 3 of 50. Right, so now I'm drawing a red marble, 3 out of 10. I replace it and draw another red marble, so 3 out of 10. I replace it and draw another red marble, 3 out of 10. This is 3 times 3 times 3, 27 out of 1,000. So that is probability with independent events. Now, sometimes you have to find the missing probability. So you want to think of that formula P of A and B equals P of A times P of B. Oops. So in this case, P of A and B catch that? P of A and B equals 0.7 times 0.5. So that's going to equal 0.35. That is our missing probability. Now here, we almost have to work backwards. We know P of A and B is 0.24, and that should equal 0.8 times so we had 0.24 equals 0.8 times P of B. So since I want to find what P of B is, I'm going to divide by that 0.8, and we should get 0.3. And if I check it, 0.8 times 0.3 will be 0.24. Right. Now, probability with dependent events is P of A times, this means the probability that B occurs given A has already happened. So we have to take into consideration what happened in our first. So the probability that event B occurs, given that A has already happened, we have our box of marbles has 3 red marbles, 6 blue, 1 white. What is the probability when we are not replacing? So you always start with what's there first. So I start with that red. So 3 out of 10 marbles. But I now have this 1 red marble in my hand, or this 1 marble. So the probability of me getting a blue marble is now 6 out of 9. Since I took 1 marble out, I only have 9 marbles left. And then we multiply. 3 times 6 is 18 over 90 to So I now multiply these. 3 times 6 is 18 over 10 times 9 is 90, which equals 1 out of 5. So now I'm looking at the probability of picking a blue marble and picking a blue marble the second time. So the first time I pick a blue marble, there's 6 out of 10. But the second time I pick a blue marble, well, now I only have 9 marbles left. And because I already have a blue marble, I only have 5 blue marbles. So 6 times 5 is 30 over 90, which equals 1/3. So now we have the probability of a white then a blue marble. So 1 out of 10 for our white times, there's still 6 blue marbles, but I have that 1 white marble, so there's only 9 left. So 1 times 6 is 6, 10 times 9 is 90. This is going to equal 1 out of 15. All right, now we're looking at the probability of picking a red marble all 3 times. So the first time I pick a red marble, it's 3 out of 10. Now the second time, there's only 2 red marbles left, and there's only 9 marbles in the bag. Now the third time, there's 1 red marble left and 8 marbles in the bag. So 3 times 2 is 6, times 1 is 6. 10 times 9 times 8 is 720, which this then reduces to 1 out of 120. So the chances of drawing 3 red marbles in a row is very small. So now we are trying to find our missing probabilities. So P of A and B, we get that from taking point 0.2 times 0.6, which is 0.12. P of A in our second example is 0.25. P of B given A is what we're trying to find. We know that P of A and B is 0.1. So in this case, it's 0.1 equals 0.25 times the probability of B given A. So I need to divide by that 0.25. When you put that into a calculator, we get 0.4. So that is our multiplication rule with probability.